So welcome once again. I'm Teacher Arnold. So today we are discussing inorganic chemistry, that is qualitative analysis, chemistry 233/3. And I have a question on qualitative analysis for identification of cations and anions as it is shown in the chart. Now, we have a procedure which is given, and I will read. You are provided with solid T, which is a mixture of two compounds. Carry out the tests below. Write your observations and inferences in the spaces provided. Place all solid T in a clean, dry pouring tube. Add 5 ml distilled water and shake thoroughly. Filter the mixture and keep both. Filtrate the residue. Divide the filtrate into 3 portions. Then the first portion, you're supposed to add sodium hydroxide, a few drops, then excess. Now, I've said it before that when you are given a compound which is not known, and it is you're supposed to add water and then you filter, then most definitely it means you have a soluble and insoluble salt. And in this case, you're supposed to mention the color of the filtrate and the color of the residue. For this case, we have a blue filtrate and a white residue. So our concentration should be on the residue and the filtrate. So the observation which was made in this experiment is that a pale blue precipitate insoluble in excess. So that is what was seen in this experiment. A pale blue precipitate which was insoluble in excess. So for that case, the inference will be copper ions present, because we know it is copper ions which are blue in color. And then the second, Roman 2, add aqueous ammonia dropwise the second portion until in excess. So in this case, the observation which was made is that blue precipitate insoluble, that is what was seen. So under the inference, it means you are going to confirm the presence of copper ions present. And the inferences, those ions must be written properly. Now, in part B, rinse the residue with the distilled water, and then you transfer it into a clean pouring tube. Then you add dilute nitric acid, which is provided then dropwise, then until all the solid dissolves. Remember, you are washing the residue to remove a possibility of any copper ions which was present, because copper is soluble. We have seen it before. The copper salt was soluble in this case. Now, the observation which was made here is that number 1, effervescence was observed. Or we will say purples of a colorless gas was produced. Then number 2, the solid dissolves. To form colorless solution. So that is what was seen under the observation. So under the inference, if you are adding nitric acid and then you see effervescence and a colorless solution is formed, then it means there was a possibility of a carbonate and a sulfide, or either one of them was present. Because in a carbonate, that is production of carbon dioxide, then from a sulfide, most probably there was a presence of SO2 gas produced, that's sulfur dioxide gas. Then divide the certain solution into 3 portions, and then the first one you add sodium hydroxide dropwise until in excess. The observation which was made here is that a white precipitate soluble in excess. That is what was seen. So white precipitate in excess was soluble. So if that is the case, we mentioned the ZAP, that is zinc, aluminium, or lead ions present. That is what we call the ZAP. Now, if you are adding now the Roman 2 aqueous ammonia, the second portion, and then in excess, the observation which was made is that the white precipitate insoluble in excess, that is what was seen. So there was a white precipitate in excess, it was insoluble. So if it was to dissolve, we could have said zinc ions present. So if it is insoluble, then it means it is aluminium ions and lead ions present. So remember, this is an eliminatory method where we eliminate the ions until you remain with the ion which is present. So we've eliminated zinc, and we have now 2. We add HCl, which is dilute, to now confirm which ion is present actually. So when you add HCl, it means we are getting the chloride from here, react with the cation, aluminium or lead. You know very well, aluminium chloride is soluble, so if you see a colorless solution formed, you confirm aluminium ions. But lead chloride is insoluble, but on warming it dissolves. So they are saying, and warm the mixture. So the observation which was made is a white precipitate which dissolves on warming. So if that is the case, white precipitate and then it dissolves on warming. So that must be lead chloride. That means lead ions are present. Alternatively, you can be given sodium iodide to differentiate between the two. So if you see a yellow precipitate, then you confirm lead ions. If no yellow precipitate is formed, you confirm aluminium ions. So that is what we had today. Hope you enjoyed. Let us meet next time. Thank you.